Welcome to a presentation from Swoosh Technologies and Solutions. Today's presentation will talk about how to work with multiple revisions of non-NX data. So an example would be customer sends a step file. I open it in NX, I work on it, edit it, add good value information to it, and then they send revision B. So I somehow need to replace revision A with revision B and maintain as much of that good value added information that I put in the part as is possible. So we all know that for working with that non-NX data, it's very easy to open that. You just say File Open. There's a filter in the Open dialog. You can pick Inventor, Solidworks, Catia. You can pick Parasolid. You can pick IGES files, lots of file types there you can pick and open. You'll work with them, create drawings, add dimensions. In manufacturing, you run toolpaths on the faces and edges. And that's what I really want to focus on in this, is how the manufacturing people can deal with saving their toolpaths and not having to recreate them. That is what the challenge becomes. How do I get that part in? How do I swap out the original part for the new revised part? Now within NX, this isn't a problem. If you start working on a file in NX, it's revision A, then you do save as to create a revision B part. It passes all of the face information from revision A to revision B, and it does that based on unique identifiers for faces and edges. So it knows how to transfer that data. But guess what? In a non-native file, it doesn't have anything to transfer. There are no unique identifiers on it, so we have to have other ways to transfer that information. And that's what I'm going to show you in my demonstration for today. So here's a part file. It was originally a step file. I opened it in NX. Looks pretty good. There wasn't any errors with bringing it in. Okay. I can look at the model navigation tool and see, yep, it's a dumb, solid, unparameterized body. Nothing there. So following kind of best practices, if I'm the manufacturing person who's going to machine this, I would open the part file, then I would say I want to create a new setup file for it. If you were a drafting person, you would have the engineer model open and you'd say I want to create a new drawing for it. It's the same idea. Okay. And it will create a setup file with a lot of information can be brought across in that setup file. And the part gets added as a component. Now what most people will do is to take the part that was added and create a linked body, because generally you can't play with the engineering model. Manufacturing people can't. They're not supposed to edit it, but sometimes you need to tweak a little bit of, radius is off by 1,000th or something small. So by creating a linked body that you, the manufacturing person, owns, you can make those kind of edits and they don't affect the engineering model. So I created a linked body here from the component, and I like to change its color to something obnoxious. In this case it's a emerald green, so that I know when I'm working on the linked body versus the original part. I can come in and look at my toolpaths. I have several operations here. I can highlight them, take a peek at them. Let's see, variable axis contour. These are all associated to the faces of revision A part. Okay. Then comes, well, before I do that, let's look at drawing. It's nice that in manufacturing, if you want to create a setup file or setup drawing, you can do that directly. I'm just going to say application drafting. Create a little format sheet here, drop some views on it, and put some critical dimensions in that were needed for purposes of mounting it to the fixture or clamping it in a vise. So that's in there too. So we've got this revision B we're dealing with. Some obvious changes, maybe not so obvious if you don't know what the part is. So what I always like to do when I get revision B is try to get the system to show me what's different. And I'll do that with the Model Compare tool. When you go into Model Compare, the Q line will be prompting me to pick the first part that I want to compare against the second part. So I'm going to jump back to my revision A part and pick it as the first one. I'll show you the importance of that in a moment. Then I'll go to the revision B part and pick it. So the screen splits into three parts. The first are three views. The first one I picked is up here in the top left. The second part that I picked is in the top right, and the lower view is a combined view. Whichever one my cursor is in is the one that will rotate and be manipulated. Now I'm in here only to try to find out what changed. So I'm just going to touch on some of the options in this dialog briefly. I generally like to turn on the edges for both revision A and revision B parts. I'm not concerned too much about the faces that changed, so I'm going to turn those options off. What I am interested in are what faces are unique. That's what the third button is. And I'm going to say make the unique faces of part 1 a bright yellow, and the unique faces of part 2 maybe magenta. So I've got those colors set, I've got check marks in front. All I have to do is find the Do It button. Show it to me. Well, that's, you hit apply. And there we go. These are the faces that are unique in revision A, revision B, and the overlap of them down here. Now, why the unique faces are most interesting is they're the ones that you, if the revision B added a hole, I would have to be aware that's a unique face so that I add it into my machining operation. So I like to point out those things coming through here. So I've had a look at it. Looks pretty good. I'm ready to bail out of my Model Compare tool. I'm going to go back to my setup drawing and get ready to do the transfer. Okay. First step in swapping the two parts is to add the revision B part as a component into the setup file. So add component, I'll pick revision B, okay, and just dropped it on top of the original. I didn't mate or constrain it. You can do all of those things if you want. Second step of the process is I want to change the linked body that's currently pointing to revision A and make it point to revision B. So I'm going to edit the link. I'm going to deselect with a shift pick the revision A component, and then I'm going to select in its place the revision B component. So now the system knows to trade them out, but it still doesn't have that knowledge of which face in revision A is the same face in revision B. We can help it with using the replacement assistant. I'll OK that automation message. Now if you've used this before, and by the way I have my views being synchronized, let me pull this window up a little bit. I have the synchronized toggle turned on so they move at the same time, which is kind of handy for what we're about to do, transfer face in one to face in the other. System's prompting me right now to pick a face in revision A and a similar face in revision B and transfer it over. And then you pick the next pair and the next pair and the next pair until you had them all resolved. And that's kind of a painful process to do one at a time, especially on a complicated piece of geometry, which this is not that complicated. So the third step I like to do coming into the first step was we brought in revision B, we changed the link, and now we're in this replacement assistant tool. I'll tell the system, find what you can of geometric matches. In other words, the face in the original matches the face in revision B. And I'll activate that. And if you're dealing with IGES geometry, you can loosen the tolerance up a bit here. But when you're ready to go, you just hit find. Now the system found some matches. In the lower right hand corner, it's telling me it found 67 faces and edges that it can match. It's previewing them. They're this dark charcoal color, and that's determined by the color widget here in the dialog, dark charcoal. That's fine for me. I can go through the list here and pick some of the faces and see where they compare, make as much distinction as I want between those two and say, yeah, that's right, or no, it's not. And if it wasn't a good match, I could delete it from this list. But I like them. Right now, they're only tentative. They got little lightning bolts on them. So that means the system isn't ready to use them yet until I accept them. So I can come over here to this list and go to the top and pick and shift pick the bottom and pick everything in between. But if I just activate this window, Control A will pick all of them, and then to accept them I have a check mark over here. So they have a lightning bolt when they're tentative. Check mark makes them accepted. So I've accepted those faces. Now I'm going to ask the system, based on those things that those clues that I gave you, NX, can you figure out any other faces? Come up to the drop down, say infer from accepted faces. See if you can figure anything else out. So I'll make that choice. I'll hit the binoculars, and oh yeah, found 95 additional faces and edges. I like them. I'm just going to click in this window to activate it, Control A to select them, and hit the check mark. They're now accepted. Now at this point you can run it again, or you can begin to transfer some faces. I want to show you how the transfer works here, at least with a few faces, and then we'll move on. So if I decide to manually transfer faces again, I'm going to change this to geometric, and I'm going to pick the Add New Matches icon, which will activate the selection widget. And I'll pick a face in revision A and say that matches this face in revision B. And you can accept that, or the shortcut to do that is middle mouse button accepts. And you see they turn black. Okay, I'm going to repeat the process. Face here, face there, middle mouse. Face here, face there, middle mouse. Now I've done a few of these. I'll let the system see if it can figure any more out. So I'll change my settings back to infer from accepted. Hit the magnifying glass. It found 40 new matches. Not too shabby. Get in this window to activate it. Control A. Select them all. Accept them. Okay, we're doing pretty good. Actually, the only things that could have been transferred are the two holes. The blends here, they were not on the original part. Okay, got it. I'm going to come here and say create new match. Face in the original, face in the replacement part. Middle mouse to accept. Face, face, middle mouse to accept. All right, I'm going to come to the top and give it one more go of let it try to find the remaining faces. It says it found 6 faces and edges. I'll accept them. Control A to pick them. Okay. Try it once more. Found 2 more based on those that I just accepted. I can accept here too by picking and saying OK, or the check mark. And I get to a point where the message at the bottom is saying all objects from the old parent have been reattached. You have nothing else you can do here. You've done as much as you can. Say OK to complete the setting. Okay. So now I've transferred all of as much data as I can from revision A to revision B. I'm going to hide the revision B component so that I'm only looking at the link. Because I changed parents, it lost its color, so I'll go back in very quickly here and make it the obvious emerald green. Okay, so now I know it's linked again. And we're ready to look at how the system could do with that associated geometry. Let's look at the drawing first. So I'll say application drafting. The drawing was in this setup file. Well, so far so good, but we haven't updated the views. They're all out of date. So pick the drawing node. I'll say update. And it did pretty good at transferring them over. I've got one dimension here. It doesn't surprise me it got lost because revision A had a sharp corner. This has a round corner. So I just edit that dimension. It tells me that this is the second object and it knows where it is, but it lost track of the first object. So I'll just come down here and pick an edge where I want to tie it to, close it. So I had a little bit of repair there to do, certainly not too much. Now let's go over to manufacturing and see how we did. Here's the manufacturing file. We'll go to the operation navigator. All of the operations are out of date, as would be expected when you change anything. The key trick will be, will they update? So I'll pick the top node here in in the navigator, and I'm going to ask it just to regenerate all of those toolpaths. And while it's doing this, I'll review a little bit of where we went. So if you're working in exclusively an NX part file, there's no problem going from revision A to revision B. The UID, the unique identifiers on the faces, will transfer over, and it should be pretty painless. The only thing you have to watch for is if there are new faces created in revision B. That would be true here also. If the engineer added an additional hole or a pocket or pad, naturally it's not going to pick them up automatically for machining, that you'd have to go in and add them to the operation or create a separate operation for them. Okay, this is ticking along pretty nicely. I get a message that says it's all done. Do I want to accept the paths? And I do. They've all updated here. The adaptive milling, the variable axis contour milling, it's now associated to the revision B part. Very good. So in summary, you can do this pretty easily. Let the computer work for you. Don't do all the picking yourself. Also, if you say, well, my company doesn't work master model, we put the manufacturing data right in the part file. Well, that's okay. You're not out of luck yet. It's just you can't do a wave link. But what you can do is extract geometry and pick a body. So you're making a copy of the solid body, preferably on another layer. And then when you have to deal with revision B, the second part, you will still have the replacement assistant available to you. It gets kind of clunky if you're not working master model, but if you have a master model drawing, it would work the same way. I'd add in revision B, go through the change, life is good. So I hope you've enjoyed this and found some usefulness out of it. These part files are available. There's a link published here that you'll be able to follow. You can pull the part files down and follow along step by step with the process. Thank you very much for attending, and we look forward to seeing you at a future presentation.